Section 4.4, it has some similarities to what we've done with congruent triangles. Let me put a triangle here, and let me show you some stuff. Let's make it a little bit thicker. There we go. What I'm going to do is I'm going to copy and paste this. So what's true about these two triangles? If I copied and pasted it, tell me something that's true about these two triangles. They're exactly the same, or what's the word that we've been using? They're congruent to each other, okay? If I copy and paste, they're exactly the same. All right, I did that on the other lesson, didn't I, where I picked this up and I put it right on top of it, all right, and you can see that they're exactly the same. Let's label these A, B, C, and let's just call it X, Y, Z, just to be different than going D, E, F. Okay, so these are congruent triangles. So what do we know about all the sides? We know all 6 parts are what? All corresponding parts are what to each other? Are congruent to each other, exactly right. So I know AB, right, will equal XY. I know that BC equals YZ. I know that AC equals XZ. What else do I know about it? I know that angle A equals angle X. I know that angle B equals angle Y. And I also know that angle C equals angle Z. We just finished going over section 4.3, and that's what they wanted you to do basically in that whole section, right? Name all the corresponding parts and which ones were equal. So we know all that stuff is true. But what's kind of cool about this, let me get rid of all these tick marks. Okay? So we know all that's true, but guess what? We don't have to know all 6 things in order to say that these triangles are congruent. And that's what we're going to do the next 2 lessons. We don't have to know all 6 things. I don't have to show you that all 3 sides are equal to each other and all 3 angles, corresponding angles, are equal to each other. All I have to do is I've got 4 different theorems that we're going to do, okay? And this is our first theorem. Watch this. If I showed you that those 2 are equal, now that's not enough to say that those triangles are congruent. What if I showed you that these 2 sides are equal? That's still not enough to show that the triangles are congruent. But watch this. If I was able to say that BC was equal to YZ, if I was able to show 3 sides of one triangle congruent or equal to 3 sides of another triangle, I don't even have to say anything about the angles. For instance, if I gave you like toothpicks and they were all 3 different lengths, okay? So I gave you toothpicks on this one, they were these 3 lengths, and then I gave you the exact same lengths, 3 other toothpicks that were the exact same lengths. And I said, put a triangle together. So if you took these lengths and put a triangle together, and somebody else put those exact 3 lengths together and make a triangle, guess what's going to be true about those 2 triangles? They're going to both be exactly the same. Now, one might be like twisted around or something, right? One might look like that, but does that mean they're not congruent to each other? Now, they're still congruent to each other, aren't they? Just because it might be twisted around. They're all exactly the same. Okay? So that's all I need. I don't even have to say anything about the angles, and that's the nice thing about this particular theorem. So what do I have? I have 3 sides of one triangle congruent or equal to 3 sides of another triangle. So I call this, write this down. This is super important. I call this side, side, side. All right? And this is actually a postulate. Do you remember a long time ago we talked about the difference between a theorem and a postulate? A postulate, listen, a postulate is just an accepted fact. You just believe it, okay? They tell you it's true, it's true. All right? You don't have to prove it. You just have to believe it, all right? This is something that's true. Now, you could demonstrate that it's true, like the toothpick thing. If I gave you 3 different lengths with toothpicks, and then I gave you another 3 different lengths or the same 3 lengths, right, again, of the toothpicks, you're going to get the same exact triangle. It doesn't matter how you configure them, you will get the same exact size and shape of the triangle. All right, and that kind of shows that side, side, side is true. Now, instead of writing out side, 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 okay, we can write it like this. We can just use the S's, all right, and just put SSS. Now, we say, watch this, we say side, 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 but we write SSS. So if I asked you, why are these triangles congruent to each other? You wouldn't tell me SSS. What would you say? side, side, side. Everybody got that? Okay, but when we write it, we just use the S's. But when we say it, we use the actual words. We say side, side, side. All right? Now, they're also going to say, what is the congruent statement? So if I wanted to write a congruent statement with this, I could call this triangle anything, right? You could call it CAB. Let's do that. Instead of going to ABC like we normally do, let's go CAB. So if I call this one CAB, what do I have to call this one over here? So if I went CAB, I have to go what? Z, X, Y. Now let me show you something also that I didn't talk about the other day. How do you know that C and Z are equal to each other? Watch this. What I do, you could look to see like what sides it's in between, but I do this. This angle C is opposite the side with one tick mark, isn't it? What angle is opposite the side with one tick mark over here? Z is. Do you see that? See how it's opposite the side with one tick mark? So they have to be equal to each other. So C and Z would be equal to each other. Now, they didn't tell me they were equal to begin with, did they? But now that I know that the triangles are congruent, now I can pick this triangle up, sit it right on top of this one, and guess what's going to match up? The C and the Z. Does that make sense? What about B? What angle is B opposite? Or, sorry, what side? I didn't say that right. What side is angle B opposite? The one with two tick marks. So look over here. Here's the one with two tick marks. What's opposite that? The Y. So that would be equal. Everybody see that? Because sometimes it's not so easy. These are sitting right next to each other, nice and pretty and perfect. Okay, I copied and pasted. I didn't twist anything around. I didn't flip it or anything like that. It's just nice and pretty. So you can kind of just look at it and tell. But sometimes what they're going to do is, like I did before. I'm not going to do it now. It's too messy right now. But sometimes they're going to take the second triangle. They might twist it a little bit. They might flip it. You know what I mean? Like flip it inside out. And it's going to be hard to tell which angle goes with which angle. So how can you tell? You go by what angle or what side that angle is opposite. And of course, what would be opposite the 3? That would be angle A. And what's opposite the 3 tick marks over here? Angle X. Do you see that? We'll be referring to that kind of stuff a lot. So that what I just did right there was fairly important, okay, for what we're going to do a little bit later. Everybody with me so far? All right. So that's kind of cool. I don't have to show all 6 parts. All I have to do is show 3 sides of one triangle congruent to 3 sides of another triangle. That means that those triangles are going to be congruent. And if the triangles are congruent, what must be true about all the corresponding parts? They got to be congruent as well, right? Make sense? So watch. If I took this triangle, picked it up, and put it right on top of here, see how everything matches up? Okay, it all matches up. All those angles are equal, all these sides are equal, and that kind of thing. All right, let's do another one. Let's choose a different looking triangle just to be a little different here. And you can do this with it. It doesn't have to be obtuse. I just picked one just to be different. Let's call this something. I'm tired of ABC. Somebody give me your initials. Anybody have initials that are all the same letters? K, J, D. All right, give me another one that doesn't repeat any of these. CBH. I heard CBH first, so CBH. Sorry. All right, so here we go. Here's another way to prove that triangles are congruent by not having to know that all 6 parts are equal to each other. All right, so this one would be like this. Watch. If I was able to know, if they told me, all right, that this side was equal to this side, so KD and CH are equal to each other, all right, and if they told me that, let's say, that KJ was equal to CB, all right, now, I mean, I didn't measure it. They just told me that they're equal to each other. They could have put numbers here. They could have said this was 15 and this was 15. They could have said this was 7 and this was 7. You follow me on that? All right, so you know those are equal. And watch this. Now, that's not enough to say that those triangles are congruent, but what if they told me this? What if they told me that that angle right there is congruent to that angle right there? This is another one, okay? It doesn't matter. Again, let's go toothpicks again. If I said, I give you a length of 15 and a length of 7, and I give you another length of 15 and a length of, oops, not 17, of 7. Okay? Pretend you have toothpicks. I gave you two toothpicks, and this is 15 centimeters, and that's 7 centimeters. Okay? It's a long toothpick, but you get the idea. And I said, okay, put those toothpicks together, but they have to come together at the same angle. All right? So this angle between those two toothpicks have to be exactly the same. What do you think must be true about that third side? Think about it. If I gave you 2 toothpicks and I said, okay, arrange these 2 toothpicks at a certain angle, let's say 30 degrees, and this is 30 degrees. Is there any way that one person, that Sarah, could make a different triangle than what Owen could make, given those things right there? There's not. The triangle, if I had a third side, if I had a third toothpick and I connected them, you would have the exact same triangle. There's no way in the world that you could get a different looking triangle. All right? And so what did we show right here? We showed, is that us? Oh, somebody move my clock or it's going slow. Let me just say this real quick and we'll go. Watch. This is a side. Listen, listen, listen. Don't pack up. Write this down. Write this down. I've got a side, I've got an angle, and I've got another side. I've got a side, an angle, and another side. So guess what I call this? I call it side, angle, what? Side. Now, I say side, angle, side, but I write what? SAS. Okay, I'm not giving you homework tonight, but you will have work to do in class tomorrow. All right, and I'll give you some more hints tomorrow about how I want you to do the homework, okay? Make sure you have those notes. If you didn't take notes in class, then watch the video tonight and take notes on it.